Okay, my little baby, we're going to be learning about neural networks. Neural networks is how the brain carries information from one point of the brain to another point of the brain, and then from that point of the brain to another point of the brain, and then from there to the last point of the brain, or another one. So, let us begin. Give the neuron input and output, and it can help us learn. We covered neurons in another lesson, but they are little cells inside your brain that can collect and store information. Give the ball input and output, and it acts like a neuron. So when we input information into the little ball, it then outputs information to other cells. The neuron can have one input and output. So the neuron can have just one source of information going in, then being carried off to the rest of the neurons, or the rest of the balls, or many inputs going in, and many outputs going out. So that means it could have multiple sources of information going into one neuron, or it could have multiple outsources or outputs of information coming out from one neuron. Is there a red animal in this picture? Is there a red animal? Can you look at this picture? You can see it, right? Can you tell me what color this is? It's blue. Can you tell me what color this is? It's brown. Can you tell me what color this line is? It's white. Very good. And can you tell me what color this is? Yeah, it's red. And this looks like a starfish, right? Can you tell me if a starfish is a living animal? It is a living animal. Can you see a red animal in this picture? Yeah, we can see a red animal in this picture. So, the neuron can decide based on its input. The neuron can decide based on its input what it's going to store inside of its neurons, what it's going to capture. So, right now your brain is noticing that you saw red, which is going into your neurons. It's noticing that it saw another red, which is going into its other neurons. It probably broke the picture up into little bits inside of your head that you then started to add up in different ways when you're observing, and it's all being processed by a neuron that's collecting all the information. When the neuron has an answer, which here's the neuron, we saw 3 parts red because that's what we were looking for. If someone says red, the input of information is to look for something red, which is probably already stored in our neurons, telling us that certain pigments or certain refractions of light reflect red, and that the name of that pigment or the name of that refraction is red. And so when we see that color, then we're going to only observe that color when someone calls it out. So we collected all of the information we needed, all of the inputs came in, and then our output was to look for red, which we found. And it sends its own message. So when the neuron has an answer, it sends its own message. It sends a message out to the rest of the neurons to look for red. See? So we have a full red neuron, or a neuron trying to look for the color red. Does this animal have 8 arms? So now it's going to exercise a different part of your brain, where not only are you trying to have your eyes tell you what color something is, but now you have to exercise the part of your brain responsible for math, adding and subtracting, simple math. So, can we count how many arms the starfish has? Yeah, let's count it up. It has 1, 2, 3, 4, 5, 6, 7, 8. Does this animal have 8 arms? Yes, it does. So, our mind then having to process that information counted up how many arms the starfish had. the neuron can decide based on its input. So in your brain, you might have tallied it up using it going by 2s. We only went by 1s. You could also go by 4s. Split the starfish in half and count half of it and then the other half. So once all of the information was inputted into the neuron added it all up and said that there was 8. And then we knew that there was 8 arms on that starfish. That's when the neuron has an answer. It tallies up all of its information that it's trying to find. And it sends its own message. It communicates that information to the rest of the brain cells, which then locks in that newfound information and allows it to go into storage. Where do the messages go? Where do the messages go? So, when it's going into output mode, because input is what we observe around us and how we process that information. But once that information is processed, where does it go? Neurons talk to each other. They connect together in a network. So here's a ball connected to here. This ball's connected to this one. This ball's connected to this one. This ball's connected to this one. This ball is connected to that one. This ball's connected to this one. That ball's connected to this one. They're all interconnected with one another. That's how neural networks work. They're all communicating with one another, telling each other the information they might or might not need. So, input neurons look at parts of the picture. So these are all input neurons. They're all the ones processing the information from the outside world. Here's the example of the starfish, where it was breaking down the image and trying to analyze what is it observing. Where's the color that's in question? What is the subject that's in question? Was there an animal in the picture? And if there was an animal in the picture, was it red? And once we have all of that information inputted, output neurons have answers about the picture. Once we have all of that information in place, then we can confirm that we have a red animal in the picture. That's what the output neurons are sending as a message to the rest of the brain. We also analyzed if there was an 8-armed starfish, and then here's a random 5-armed yellow starfish that was not under discussion previously. Neurons in between don't see the pictures or give answers. They are hidden. So neurons in between don't see the pictures or answers. They are hidden. There's a whole interconnected network of neurons that are neither input nor output. And, well, I guess they're all input or output, but they're not the ones that are expressly used, or at least obviously used. How do the hidden neurons learn to decide? What do the hidden neurons do? Training data can have correct labels on them. So we have green starfish with 7 arms, blue starfish with 8 arms. We have a yellow starfish with 5 arms, and then we have a red starfish with 5 arms. And then after training, the network has learned to label new pictures. Interesting. But what about the hidden neurons though? How do the hidden neurons learn to decide? Oh, I see. Through education, whether it's memorization or real life practice, sensory examples or sensory exercises, that's how your brain learns to process all of that information and then hides it or stores it in the hidden neurons that then work as intermediaries between the inputs and outputs because they're where the stored information is located. A really big network can solve even harder problems with the help of computers. Wow. So, the bigger the network, the more information and the harder the questions you can then answer. That's why 2 heads are better than 1. That means you have way more neurons with information stored up in them than you do with just one person. You double them, allegedly. Because there's some people where it's almost like 1.5, but then there's others where it's almost like you triple them. Now you know neural networks. The end. So, do you feel like you're confident enough to understand neural networks now? No? Oh, that's okay. You were just freshly born. It's not like you can really understand brain cells yet. Mostly because I can see your brain pulsing in your skull. Your skull hasn't yet formed, little baby. So, in that case, we will recap it later when your skull has finished forming and I can no longer see your brain going. Bye-bye.